name is CJ, and today we're going to learn the rational zero theorem. Now, before we get started, a couple of important key terms that we're going to need to know are P and Q. P stands for the constant, and Q stands for the leading coefficient. Remember those two things. Okay, let's get started. Now, we're going to list all the possible rational zeros of this function. Okay, the function is 9x to the 6th minus 5x to the 3rd plus 27. Now we have to find the constant and the leading coefficient of the function. Constant is 27. Write it out. P equals 27. Now we find the leading coefficient, which is 9. Q equals 9. And now we find the factors of both P and Q. Factors of P, plus or minus 1, plus or minus 3, plus or minus 9, or plus or minus 27. Factors of Q, plus or minus 1, plus or minus 3, plus or minus 9. Okay. Now we put the factors of P over the factors of Q. They're going to be fractions now. So P over Q equals plus or minus 1 over 1, plus or minus 3 over 1, plus or minus 9 over 1, plus or minus 27 over 1, plus or minus 1 over 3, plus or minus 3 over 3, plus or minus 9 over 3, plus or minus 27 over 3, plus or minus 1 over 9, plus or minus 3 over 9, plus or minus 9 over 9, and finally plus or minus 27 over 9. And before we finish, we have to cancel out any repeating fractions. So 1 over 1, 3 over 1, which is 3, 9 over 1 is 9, 27 over 1, 27. 1/3, 3 over 3. We already have 3 over 3, 1 over 1 is the same thing. Cancel it out. 9 over 3 is 3. Cancel it out because we already have 3 over 1. 27 over 3 equals 9. We already have that. 1/9, 3/9, which is 1/3. Already have that. 9 over 9, we already got it. And 27 over 9 is 3, which we already have. In this example, we're using the list of rational zeros to solve the function by finding all the roots. When finding the roots, you start by plugging in possible rational zeros into the polynomial until y equals 0. The x value in which y will equal 0 will be the first root. So let's write out the function. F of x equals 5x to the 3rd plus 12x squared minus 29x plus 12. First we find the factors of 12, the constant. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Now we find factors of the leading coefficient, 5, plus or minus 1, and plus or minus 5. And now we write out the list of rational zeros. Now there's no repeating fractions, so we don't have to cancel out anything. And now we find the first root. So we plug in any possible numbers until y equals 0. So we'll start at 1. (17 minus 29 is negative 12 plus 12 equals 0. So luckily with the first try we got 1, so 1 is the first root. So since we found the first root, now we're using the factor theorem to find the remaining roots. So we box off 1 and write out the numbers that were in the polynomial. Bring down 5. 5 times 1 is 5. 12 plus 5 is 17. 17 plus 1 is 17. 29, negative 29 plus 17, that is negative 12. And 12 minus 12 is 0. From the original function, it was 5x to the third. We subtract an exponent, so it'll be 5x squared plus 17x minus 12 equals 0. And now you just factor. No factors of 12 can make 17, so multiply negative 12 and 5, you'll get negative 60, and 20 and negative 3 are the factors that can equal 17. So now, write out 5x plus 20, and 5x minus 3 equals 0. You can reduce 5x plus 20 to x plus 4, and 5x minus 3 will stay the same. Now, we set up both of these equations equal to 0. X plus 4 equals 0, and 5x minus 3 equals 0. X equals negative 4, x will equal 3/5. And the answer negative 4, 3/5, and 1. And that is the rational zero theorem.